some comparison of the motors. So we are going straight away to that comparison part. Okay, so this is page number 101 in that PDF document provided by IntelliPet team. So now if someone asks you that there are different type of motors, for example, DC motors, induction machine, PMSM, BLDC, SRM, what are the desirable features for EV motors? That we already discussed earlier. Do remember, for electric vehicle, we want the motor to be compact, that means smaller in size. It must give higher power, higher torque in smaller size, right? That we call it torque density, power density. So power density means, in simple term, your power output per kg of weight. So higher power density means in smaller size you can have higher power. Similarly, torque density higher means in smaller frame size, smaller size of the machine, you can generate higher torque, right? So typically, we also want the motor to be lightweight. It should take less volume. It should run faster, right? It should act faster when you give control command, because in electric vehicle we want fast response. It should have a regenerative braking capability. It should be easier to take out the heat developed in the motor due to various losses. Then the motor must be very efficient. And one of the most important requirement was we should have less maintenance requirement in the machine, right? So your motor in the electric vehicle should not fail frequently, should not create trouble for you. It should give you peaceful life. So one of the traditional motor that we begin learning electrical machine with is DC motor. In DC motor, we have several categories: DC series motor with DC shunt motor, separately excited DC machine, right? Earlier days in the traction drive, that means for the electric trains, right? People used to prefer DC series motor. That's why even today, if we ask this question to some attendee, which motor you are going to prefer for electric vehicle, they say DC motor, because in their mind it is, some of those old textbooks, they clearly mention DC series motor is good for traction drive. So they think DC series motor is still good for electric vehicles. Answer is that technically yes, DC motor can be used for electric vehicles, but DC motor has several problems. Okay, major problems are there. They need higher maintenance. So DC motor, they have brush and commutator arrangement. So that creates problem for electric vehicle application due to maintenance requirement. Second thing is that they are not suitable for high speed operation. And generally DC motors has higher size requirement, higher volume requirement, all those problems. So majorly due to maintenance requirement and restriction on the higher speed, that creates a problem for the DC motor. So this brush and commutator requirement, the motor which does not have that, they are preferred for EV application. For example, induction machine, it does not need any brush or commutator. Traditional synchronous machine, that needs brush. But then to avoid that, we are using PMSM. What is PMSM? PMSM is basically a synchronous machine where in the rotor, instead of traditional windings, we put permanent magnet directly. So as a result, you don't need those brush, commutator, all those things. So PMSM is much more compact. It does not require major maintenance. These are the advantages. So if you compare these different motors, So first topic that you see is the power density. Okay. So in power density, you can observe that the machine or motor having higher power density, generally it will be preferred. So here BLDC you can see is a good choice. PMSM is a good choice. That means in smaller size, they can generate more power, right? So that's why PMSM and BLDC are very popular. Then talk about efficiency. So efficiency means higher efficiency means lesser loss, right? Lesser loss means you can have your lesser cooling requirement, generally lesser volume. So higher efficiency also signifies that you will have better electric range. So here you can see that typically this BLDC compared to other motors. That is one of the major reasons PMSM and BLDC are that popular. So typically efficiency of PMSM is higher than efficiency of induction machine. Third point is reliability. So that's how long it can last in simple terms without giving you maintenance related troubles. So here you can see induction machine is a very good choice. Induction machine is very reliable. There are mainly two reasons. It does not need any brush and commutator. Second reason is it does not require any magnet, right? So problem with magnet, if you remember, as I told, when we stick the magnet into the rotor, you have to paste it, you have to insert the magnet, and it is not very straightforward things. And sometime at high speed, there is a chance that the magnet will get broken. Another problem with the magnet is that when you go for very high speed operation, we generally operate the motor in a particular mode we call field weakening mode or flux weakening mode. There this magnet we deliberately demagnetize. So sometimes it may happen that due to some wrong calculations or some other issues, you demagnetize the magnet in such a way that magnet may lose its property. So those risk of demagnetization, risk of damage in the magnet, those things makes PMSM BLDC slightly less reliable as compared to induction machine or SRM. The problem with induction machine, as I told, efficiency is on the lower side, power density is on the lower side. Alright, so with this, we now come to a conclusion that in general, PMSM is best choice for high-end vehicles. BLDC is good generally for low power applications. Typically around less than 1 kilowatt, less than 2 kilowatt, that kind of applications, BLDC is more preferred. BLDC in general is cheaper solution, but their problem is that they have more torque ripple. More torque ripple means jerk kind of feeling, not very smooth operation, right? So the cost sensitive segments, they prefer BLDC, whereas the higher cost vehicles, they naturally go with PMSM. All right. So let me check if you have any question till now. Okay, someone of you saying voice is not clear, but I already got it checked earlier. T, are you available? Okay, so I think it may be a problem for one or two attendees. In general, otherwise it was clear. I already checked that. Okay, so now also I can see that a lot of you are mentioning it is clear, right? So those who are not getting it clear, please recheck your internet connection, or you may be rejoin. You can rejoin. TA is also not here, so I cannot get it checked by him or her, unfortunately. Sorry for that. Okay, so let me continue with the next part. Next is force calculation for motor selection, right? So in simple terms, how do we know how much torque, how much speed is required for the vehicle, and that will help us to select our required motor, all right? So first thing, let's try to understand what is tractive force. This is page number 105. Okay, so I've copied the same content in PPT. Generally, it is much easier for me to write on the PPT than in PDF. So, what is tractive force? Let us first start our discussion slowly. Now, when you want your vehicle to propel or move, right, you need to apply certain force on the vehicle so that vehicle can move, isn't it? For example, when you are driving a bicycle, you need to give good amount of pedal so that your bicycle can move. So the force here is for a vehicle, we call it tractive force. The tractive force in the contact area between the tires of the driven wheels and the road surface propels the vehicle forward. Now, what is tractive force and how it is produced? So, it is produced by the power plant, right? And for us, it will be the motor and transferred to the driving wheels via transmission and final drive. So I believe you have already taken a course on introduction to electric vehicle. You must have seen that motor output is connected to transmission unit. Generally for electric vehicle, we don't have any clutch. In IC engine vehicles, we have clutch, right? So motor output will be given to the transmission unit. Transmission unit in simple terms is the gear changing arrangement. Electric vehicle generally we have a fixed gear, right? So that's why we don't need any gear changing arrangement. And after that, it goes to the drive shaft, and then it eventually connects to the wheel, right? So a quick discussion on this in case you have forgotten or just to make our flow on the same line. So typically for IC engine vehicle, we are going to have a IC engine, but for us, what we are going to have in EV, we will have a motor, and then so we are going to have a motor, and then we are going to have a transmission unit. Then it goes to drive shaft. Then this device is called differential, and then the output of the differential will be connected through axle, and eventually it will go to the wheel. So between motor and the wheel we have multiple components, right? Motor to transmission unit, generally it will be fixed gear. Then through drive shaft it will go to differential, and then eventually to the wheels. Now, when you want to make a vehicle move, there at the same time there will be some opposing forces acting on the vehicle, right? There are mainly three resistive forces, we call them, acting on the vehicle, which will try to oppose that motion of the vehicle. What are those three resistive forces? First one is rolling resistance force, aerodynamic force, and hill climbing or gradient force. Okay. So how do you realize them? Again, yesterday we took an example that let's say you are driving a bicycle. You give pedal and bicycle is moving, right? Now, once you remove the pedal, after some time, the bicycle will automatically stop, right? Even if you don't apply brake, it will automatically stop. Why does it stop? Because there are some opposing forces acting on the vehicle, and you are not giving any tractive force anymore. So due to those opposing forces, eventually vehicle has to come to stop. If there were no opposing forces, the bicycle would have run for infinite time. But since there are some resistive forces, eventually it will come to stop. Let's understand these forces one by one, and we'll also understand how to calculate them. Okay, we'll take some examples. So, first one, to understand the overall things, we have to also understand Newton's second law. Okay, so there are two important things. One are some of the forces which opposing the vehicle motion, and then some forces are supporting the vehicle motion. So, for example, the motor, it tries to have the vehicle motion. but then those three resistive forces, they are trying to oppose it. Okay. Now, Newton's second law, what it says, let's say I have a vehicle. Okay. I am giving some tractive force to move the vehicle, and the resistive forces, F resistive, they are opposing the vehicle movement. Okay. So how they are related? So they are related by Newton's second law. Okay. What it says, the resultant force acting on a body. So what is the resulting force? F tractive minus F resistive. That is the resulting force acting on the vehicle, right? It is given by M into A. Different book follows different nomenclatures. So what is M? M is mass of the vehicle and A is acceleration. Okay. So acceleration is nothing but dv dt. V is the vehicle speed or velocity, and this V is nothing but dx dt. So x is basically the distance covered. Okay, these are again very class 11, 12 physics. So vehicle speed is dx dt, rate of change of position or distance covered by time, that is your velocity, and dv dt, rate of change of speed or velocity. For simplicity, I'm considering both of them same now. Rate of change of speed is acceleration. Okay, so Newton's second law says F tractive minus F resistive is mass into acceleration. Okay. So here there can be three cases. Let's try to understand. Case 1, we have applied tractive force more than resistive force. So in that case, you can see that this mass into acceleration, this will be a positive number. I hope you are getting the simple arithmetic things. So if F tractive is more than F resistive, what will happen? This resultant thing will be positive. That means mass into acceleration will be positive. So that means A, acceleration is positive. That means speed will keep on increasing. Isn't it? A positive means dv dt positive. So dv dt positive means dv has to be positive, because we know time can never be negative. Time has to be always positive, right? So acceleration positive means speed will keep on increasing. Okay? So if someone asks you, if I want to accelerate a vehicle, what I have to do? We have to apply more tractive force than the resistive force. Okay? Case 2, if tractive force is same as resistive force, then what happens is MA, this becomes 0, right? Because resultant force acting on the vehicle will become 0. So acceleration 0 means dv dt equal to 0. So what does it mean? V constant. Right? Again, class 11, 12 math. If derivative of anything is 0, that means either that is 0 or it is constant. So V has to be, constant. That's why its rate of change of that value is also 0. So if you want to maintain a constant vehicle speed, you have to apply a tractive force which is same as the resistive force, right? That they will balance each other and the system will run at equilibrium at constant speed. Think about case 3. F tractive is less than F resistive. Okay, so that means you are applying less tractive force than the opposing or resistive forces. In that case, MA becomes negative. That means dV dt, it becomes negative. That means vehicle speed, it will reduce. So for example, when you want to apply brake or when you want to stop, then the tractive force we generally apply less than resistive force. For example, if you just remove the tractive force, what happens? That example of when you withdraw your pedal in the bicycle, that means this tractive force becomes zero. So then only resistive force with the negative sign, that is equal to m into a. So naturally acceleration will become negative and vehicle will stop. This is how you need to relate all this very simple physics or math together. Let me know if you have any doubt till now. Of course, we are going to learn how to calculate these resistive forces one by one. Okay, so some of you are having network issue, I guess. Tia, are you available? I just want to check one more time. Tia, are you there? Okay, so can some of you again type whether it is clear, my audio is clear or not? Okay, for one Sahil Garg, it is not clear. For other candidate, can you please type whether you can hear me clearly or not? So you just write clear or not clear, maybe that is okay. Okay, clear most of the time. So those who are having my voice is not coming clear, so I guess you understand it is due to your internet connection or maybe something from your side, because majority of the attendees, they are saying it is clear. So I'll go ahead with this. Thank you so much for your support. Now let's start calculating these resistive forces and understand them slowly. So first one is rolling resistance force. So what is the term rolling means, right? When the wheel rolls, you can associate. So basically, when a wheel is rolling, there is a friction between the wheel and the road. Very simple, right? When the vehicle is moving, there will be always some friction between the road and the wheel. So that is a resistive force. And how do you calculate? This resistive force is given by mu mg cos alpha. Okay, mu mg cos alpha. Please note down this equation. FRR is mu mg. FRR, that means force due to rolling resistance, is mu mg cos alpha, and unit is Newton. Unit of force is Newton. Now, what is the first term? Mu. This mu is coefficient of friction between the wheel and the road. So it is a coefficient of friction. Okay. Now, how do you get its value? So basically, depending on the type of the road, type of the tire, this coefficient of rolling resistance has to be taken. Okay. For example, if you are talking about a car tire, typically on concrete road, so then this mu r or mu, we can select it 0.011. Okay. Similarly, let's say if you're talking about the loose sand, it goes higher. All right. So this list you can get it from internet, and of course after every class, as you know, I'll be uploading the class notes. So mu is a coefficient of friction. There is some standard chart from which you will get the value based on your type of the vehicle, type of the road that you are interested in. Okay. Next is mass. Mass of the vehicle in kg, right? Then comes g. G is acceleration due to gravity. So typically we are going to take 9.8 meter per second square. You have to be very careful about the units. Okay. Unit of mass will be in kg. Coefficient of friction is of course unitless. Then the fourth term is cos alpha. Okay. So alpha is the gradient or inclination angle. So if your vehicle is having some inclination as compared to the level road, right? It is going up or down. So that angle is alpha. Here alpha calculating degree in general. I hope this point is clear. Please take a note. We are going to solve a problem. So mu m g cos alpha. Simple. I'll pause for 10-15 seconds so that you can take a note of it. We need to solve a problem now. Alright, I believe it is done. So let's solve a problem. So the problem says, calculate the rolling resistance force experienced by a vehicle with a mass of 1200 kg, that means m equal to 1200 kg, traveling on a road with a coefficient of friction between its wheels and the road surface as 0.015. That means mu equal to 0.015. The road has a slight incline with an angle of 3 degree. That means alpha equal to 3 degree. Given that the acceleration due to gravity is 9.8 meter square. So that is the g. Okay. So all these values are given.